Okay, welcome back to another video today. It is about phylogenetic trees, and these are not actually real types of trees, but I really hope you guys like my picture here. I really just spent way too long working on this, so hope you love it. Let's get into the video now. So, a phylogenetic tree it looks like this. And the purpose of it is to show how different species are related to each other. So yeah, a phylogenetic tree, it shows who is related to who. ¿Quién está relacionado con quién? So in this phylogenetic tree, we can see that the oldest common ancestor is way back here. That might be a species that came before a tortoise or a domestic cat. This is because time moves forward on the phylogenetic tree. So this is more recent, and this is the past. So reading a phylogenetic tree, it tells us which species are most closely related. So whoever's more nearby each other on the phylogenetic tree is more closely related.
Las especies que están más cerca del árbol están más estrechamente relacionadas.
For example, the domestic cat is more closely related to the leopard than it is to the wolf. This makes sense because we know cats and leopards, they're related, and wolves are a more distant relative, but obviously cats are more similar of animals to wolves than they are to tortoises, for example. So that's why on this phylogenetic tree, it's showing us that the furthest relative is the tortoise. This particular phylogenetic tree also shows us some traits and when they developed. For example, hair. The trait of having hair developed here. So all the species on have hair. But since this trait developed after the tortoise does not have hair. Because of this, you can see that species that are more closely related will have more traits in common. Like the cat has all of these traits, and the leopard has all of these traits minus ability to purr.
Las especies que están más estrechamente relacionadas compartirán más rasgos en común.
Okay, another thing that's important to note about phylogenetic trees is that there are a couple of different ways to show them. For example, the one we just looked at looked like this. It had these angular type of branches, but they can also look like this. They can have these more square branches. It doesn't matter. It shows the same thing. What we can see here is that each branch represents a different species.
Cada rama representa una especie diferente.
So if we zoom in on species C and species D here, this was all one species all throughout time until this point. This is the point in time when species C and species D branched off and became two different species. This is called a speciation event. A speciation event is when two populations of the same species become distinct enough that they are officially two different species.
A speciation event es cuando dos poblaciones de la misma especie se vuelven lo suficientemente distintas como para ser oficialmente dos especies diferentes.
So how do we know when they are officially two different species? Well, that's when they can no longer produce fertile offspring together. So, for example, let's say we had two types of cats and they went off and lived in different places, and over time they became really, really different to the point where we thought they might be two different species. If they are still able to produce offspring together and that offspring is fertile, meaning they can also have babies, then that means that they're the same species still. If they can have offspring, but the offspring is not fertile, if it's infertile, meaning that that offspring can't have its own babies, then those things are separate species. So yeah, we can always see when this happens on a phylogenetic tree. Here we have a speciation event here, a speciation event here, and a speciation event here. On this phylogenetic tree, we have a speciation event here, one here, and one here. Back here, we had one species becoming two, so we might have called that A and C, and then A split into A and B, and C split into C and D. So let's take a look here. We have 4 different species. The first one, it says long fur. I also see that down here. Black and gray fur. I see that here and here. Hunts at night. I see that here. And climbs mountains for hunting. I don't see that anywhere else. Then for this one, I see short fur, hunts in the morning. And then this one also has brown fur. So to me, the two that are most closely related are these two. And then second would be these two. And then these guys. So I would say X and BC, those are the most distant. So I'm going to look for the phylogenetic tree that shows that. Okay, honestly, all of them show that. So that doesn't rule out anything. Now we're looking for X and Y to be closely related. So I'm going to cross out that one and that one. Now I'm looking for B, C, and Z to be very closely related. So I'm going to knock out that one. And we have our answer here. X and Y are more closely related, and Z and BC are more closely related. All right, so key points. Speciation is when two populations of a species become so different that they are eventually distinct as two species. That happens when they can no longer have a fertile offspring together, and phylogenetic trees show which species are most closely related.